So the last thing of notes that we're going to get to in your inverse trig packet is examples 14 and 15. So it says at the top of the page, we can also compose trig functions with inverse trig functions. The result is an algebraic expression that is equivalent to all of the values in your domain. As of right now, that probably doesn't make any sense, but let me explain what that part's talking about. On the last page, literally what we did at the end of last class, looks like this. If you notice, for instance, for this arc cosine, it had some ratio in the parentheses. For this arc tangent, does it have a ratio? No, it's really just an x. We could technically write this x as a ratio, but there's not numbers, and that's what I want you guys to see. Whenever there's ratios that have no numbers and you just have variables, you're going to have to do something a little different. Remember how, let me go back again, we're going to, like the second page of notes that you guys did, when we had arc sine, for instance, of some ratio that wasn't in your unit circle, we had to create a triangle. So on this page, I'm pretty much going to still do the composition, but I need to figure out how to do the composition when there's not a side length. So that's what I need to find. I'm going to make a little note at the top of the page. Since we're going to be creating triangles, I want to write out SOHCAHTOA because I'm going to need it. So for example A, I'm going to do all three questions, but for example A, I'll start with this one. You have cosine of arctangent of x. Okay, so arctangent is the same thing as tangent inverse, and with arctangent of x, this is the same as tangent of theta equals x. Think about it. Why is this the exact same as this? How did we get theta by itself? What do you do with the tangent? You do the inverse. If you do tangent inverse on each side, this side will become tangent inverse of x, which is the same thing as arctan of x. So this is pretty much the exact same thing. What this is telling you to find, so this is for the problem, you're just finding your theta. So in your triangle, when we create it, you're just trying to find out what is your angle measure supposed to be. So let me go back to the tangent of theta equals x. For tangent, we know that this is supposed to be opposite over the adjacent side. We know that because of SOHCAHTOA. The issue is for this fraction, I don't have a denominator. So Valeria, what could I put x over to make a fraction out of this? You can put it over 1. So just put it over a 1. So what I'm going to do in this space over here is I'm just going to redraw, or not redraw, but I'm going to draw a triangle. And I'm going to put theta in this little corner. First thing I'm going to do, based on the opposite and the adjacent for tangent, which was in the parentheses here, I'm going to write this as the opposite side and the adjacent side. How would I find out the hypotenuse? Because if you think about it, for cosine, this is why it's important. What's the ratio for cosine say? What do you have to find? For cosine? Adjacent and hypotenuse. So I need the hypotenuse in order to write out my theta. So David, if I was to try to find out the hypotenuse for this, what would I need to do? Think back to geometry. Help them out, guys. What can we do? Pythagorean theorem. So we're going to do 1 squared plus x squared equals, I'm going to label this as c because I don't have a side length for it yet, c squared. We're going to solve. So 1 squared is just 1 plus x squared equals c squared. And I'm going to need to do the opposite of squaring, which is to square root both sides. And remember, I'm square rooting all of this. So I'm going to have, when you square root both sides of your equation, what are you supposed to include? Plus or minus. So 1 plus x squared is going to equal c. Again, think back to geometry. Can you have a negative hypotenuse? No, it doesn't make sense to have a negative hypotenuse. So I'm just going to rewrite this as c equals the square root of 1 plus x squared. And that 1 plus x squared, guys, is going to be positive. So up here, along the hypotenuse, we're going to write 1 plus x squared. That's my hypotenuse. Let me look back at the question. David, what were we supposed to find? Look back at the problem in blue. Cosine. So in this triangle, what is cosine? Give me the adjacent and the hypotenuse for that triangle. Perfect. And this is because this is the adjacent side over the hypotenuse. So if you want to write that this is the adjacent, this is the hypotenuse. I meant to write that as a fraction, but I'll do that on the next question. Okay, last question. This has a radical in your denominator. You guys tell me, how do I get rid of that radical? What do I have to do? I have to rationalize. Do we need to use the conjugate though? I'll tell you. Since all of this is under your radical, we do not need to use the conjugate because all of this, the 1 plus x squared, is under your radical. So I'm going to still have to rationalize 1 plus x squared, but I'm going to keep that plus sign in the parentheses. This 1 plus x squared is acting as, you don't have to write this, the square root of 4 times the square root of 4. What do you do when you multiply the square root of 4 times the square root of 4? It's just going to give you 4. You're not going to have to really multiply anything. The product of these is technically 16, and then you just take the square root. So for this question, you're going to do the same thing. Since all of this is under your radical, you're just going to rewrite that denominator as 1 plus x squared without your radical, and the numerator will become 1 plus x squared. I know how we are for tests and quizzes. It'll probably ask you, especially if it's multiple choice, to rationalize. So make sure you know how to do it. As you can see, I clearly went into the space for question 2, so I'm going to need to flip my paper to the back side. So if you're still writing something, let me know because I'm about to flip. So that's all we're doing. For letters B and C, we're going to do the exact same process. So on the back side, I'm going to write out SOHCAHTOA again because I know I'm going to need it. You don't have to write it on the back, guys, unless you're like me and you write obnoxiously big. So for example 14, letter B, this is sine cosine inverse of 2x. And I kind of go overboard with putting parentheses, but it helps. All right, so we're going to do the same process. I need to look at the question, pick out the pieces that I need. In this parentheses, let me rewrite what we have. This is the same thing as cosine of theta equals 2x. Jesus, in cosine, what's the ratio based on SOHCAHTOA that we need to focus on? How would you draw that out with your triangle? What sides does it give you based on this abbreviation? And since I don't have a denominator here, what can I put the 2x over? Okay, so let me put it over 1. I need to figure out what pretty much this whole item is. Well, this whole item, we just talked about this on the last question, is theta. If you were to isolate theta, you would do cosine inverse on each side. Cosine inverse of 2x is written here. So what it's pretty much telling you is you're finding sine of theta. Before I forget, like I did on the other page, what is the sine ratio, Joseph? Opposite over hypotenuse. It's right at the top. It's okay. So let me draw this out. Once I actually find the side length for this, I'm going to have to write out my ratio as opposite over hypotenuse. So first thing I need to do in this ratio that I was given, I need to label the adjacent side. Let me label theta first. The adjacent side and the hypotenuse. Okay, that's a little different. What I still need to do, which you guys told me on the last question, is find the missing side. This missing side length I'll say is b, and you guys told me to use Pythagorean theorem. So 2x squared plus b squared equals 1. All right, so let me continue. I'm going to do, what is 2x squared? Is it 2x squared or 4x squared? Okay, good. 4x squared because you're multiplying this 2 times plus b squared equals 1. I need to isolate b. So Eurydia, what do I have to move? And once I move the 4x squared, what do I do now? Whoops. You told me square root and I immediately wrote it. 4x squared, and then we need to square root both sides. One last question, Eurydia. Do I need to make this plus and minus? Technically, yes, but you're only going to use a positive side because this side needs to be a positive value. Thank you. So 1 minus 4x squared. This will be your b value. So over here for my triangle, my b value is going to be the square root of 1 minus 4x squared. Okay, so let me think back to the question. Edgar, it told me to find sine, which was opposite over hypotenuse. In this triangle, Edgar, what's the opposite side? Oh, let's try to, hold up. Look in here. What's the opposite side? Say what you were saying again. Okay, square. I thought you just said 1. No, you're fine. Square root of 1 minus what? Perfect. And then what's the hypotenuse? 1. Do I leave my answer like that or can I simplify it? I mean, I could leave it, but is that 1 going to change your answer? No. So let's just rewrite it as square root of 1 minus 4x squared. This would be your answer. Give me some nods or shakes. Does this make sense with what we're doing? All right, this is what I'm going to have you guys do right now. In this space, because I'm definitely a little weird, in this space that I've just kind of created for you, I want you guys to do letter C. So for letter C, you have cotangent squared of cosine inverse. And I'm literally taking it from the first page. Are you okay with me writing cosine inverse instead of arc cosine? Perfect. And I'm going to put inside of the parentheses, because I'm obsessed with parentheses, an x squared. I know you're probably looking at this like, hold up, Miss Tapia, you didn't say anything about a squared. Solve it like we normally did for the last two questions, and then I'll tell you what to do with the squared. So go ahead and solve it. Try to set up your ratio. Draw your triangle, all that stuff, all those steps, and I'll tell you what to do with the squared in a second. All right, so I'm going to start simple with letter C. First, we're going to work on the inside of your parentheses. So this cosine inverse means that you have technically cosine of some angle theta is equal to x squared. We've already talked about this on the last question. Cosine is the same thing as the adjacent side, that is adjacent, over the hypotenuse. So I could put that over 1 because we've been doing that pretty much all day. So we're technically trying to find is cotangent squared of some angle theta. For cotangent, Valerie S., what's the ratio for cotangent? How would I write that? Adjacent over opposite. Adjacent over opposite. It's literally just the tangent just flipped. Okay, so let me draw out my triangle. We have theta, and we have the adjacent side, and we have the hypotenuse. Valerie S., did you find the length here? How can we find it? What can I use? Okay, so let's take x squared plus, I'm going to label this b squared equals c squared. What is x squared squared? To the what power? X to the 4th power. Just take the exponents and multiply. Keep in mind, guys, if you just kept this as x squared, which I don't think y'all did, you're not squaring it. The formula is a squared plus b squared equals c squared. You have to take whatever a is, which is x squared, and square it. Plus b squared equals 1. We're going to isolate b, correct? So I'm just going to subtract x to the 4th power. It's x to the 4th power on each side. So b squared is going to equal 1 minus x to the 4th power, and then you're going to square root both sides. So b will equal 1 minus x to the 4th power, all under your radical. Is this okay, Valerie? All right, so this is my answer for my side length. So I'm going to make the little note up here. This is the square root of 1 minus x to the 4th power. I forgot what I was doing, Valerie. What was the whole point of that? What am I trying to find? Not b. We already found it. That's this. What am I doing from here? Help her out, guys. What are we trying to find? We're trying to find cotangent. Cotangent squared of theta is going to equal, you told me adjacent over opposite, right? Adjacent over opposite? All right, Valerie, so look at your triangle. What is the adjacent side in this triangle? X squared. And what's the opposite side? X not squared. X to the 4th power. Y'all tell me, what does this squared mean? What are you probably going to have to do with your answer? You're going to have to square it. So what this squared means, so if you got to this point, you're perfect. The last thing you have to do, this little squared means that you need to take this parentheses, this fraction, and square it. So you're just going to actually square it to find your cotangent. So down here, cotangent of theta is going to be, we're going to do x squared squared, which we already talked about that. That's x to the 4th power. When you square root something that's already being squared, what are you supposed to do? Cancel it. So it's just going to be 1 minus x to the 4th power. Before I box this, I'm going to ask you kind of two questions. In this first question, can I cancel out both of these x to the 4th powers? Why not? Thank you, Edgar. There's a subtraction sign in the middle of this. That subtraction sign means you can't touch it. If there was no 1 here, then yeah, you could totally cancel those x to the 4th powers and leave it as just 1. But since that stupid 1 minus is there, this would be your answer. One other thing, I didn't ask you earlier on either of these, but I could technically ask you this for letter B. Really quick, just looking at letter B, the answer B. Can I square root both of these? Why not? It's being subtracted. I know that the square root of 1 is 1. I know the square root of 4x squared is 2x. I know that, and you know that. But you see that stupid minus sign is there? You can't touch it. If this was a plus sign, a minus sign, a division symbol, you cannot touch it. If it was multiplying, you would just multiply the numbers and then simplify. But since we don't have that luxury, we're not going to touch it. That would be your answer. All right. Any questions about A, B, or C for question 14? All right, I'm about to flip it back to the front side of the page and look at question 15. So if you need to flip, go ahead and do that now. All right, question 15. For this question, it says decompose the following algebraic expressions into compositions of a trig function with a trig inverse functions. Answers will vary. Let me be very clear with this. Answers may vary is not an answer you can put on a test or a quiz. I actually want an answer. So please don't tell me answers will vary. The other thing is, it seems kind of disgusting, but if you look at this question, so this little answer that, or not answer, this little question for letter A, this almost looks the exact same as what we had here before we rationalized. What we're doing, guys, is we're working backwards. We've already been given pretty much the answer, like we found for every single question in red at the top. What we're now finding is what is the original problem they were asking you to solve. So we need to find the original problem for each of the ones below, for each of these quote answers. So I'm going to make this as easy as possible for you guys. And we're going to start by looking at the first question. I want you to, I'm going to write this in red, write this as well. In the space right above, this is how we're going to write our answer. It's going to be some trig function times a trig inverse function, because that's literally what it said, composition of a trig with the trig inverse function. It's literally from the directions, with a ratio in the parentheses. So this is what we're going to try to find. So let's figure out how to find it. First things first, let's look at question number 1. And ironically, oh look, this is already in the same frame. You see how this has square root of 1 minus plus x squared, and this also has square root of 1 plus x squared? That's actually a good thing. How did we get, ignore question 14, how did we get 1 plus x squared underneath this radical? What did we have? What were they giving us at the beginning? Your x, which is what side of your triangle? Okay, it was the opposite side. And then what else did they give you? The 1, which is the adjacent side. So what were you missing that and you had to find? The hypotenuse. That's how we got this answer. So what do you think this answer is up here? This is your hypotenuse. So up here, I'm going to make a note. This is the hypotenuse. For this question, it's the hypotenuse. Notice that it's the exact same. It's 1 plus x squared. The reason why this is a hypotenuse is because of this plus. You have to add both of your terms if you're trying to find your hypotenuse. So I'm going to tell you how to break this up. The 2 items that you have here, which you guys told me, the 2 numbers / variable. So the 2 items that you have are your sides. Obviously, you probably already guessed it. I'm going to need the back side of the page to finish the other 2. So let's find the 2 sides, and these are your 2 sides. Okay, so let me show you how to find your sides. For side 1, we're going to take the square root of 1, because we already told me 1 was one of your sides. We're going to take the square root of 1. And then for side 2, what do you think we're going to take the square root of? X squared. Giselle, what's the square root of 1? 1, not a trick question. What's the square root of x squared? X. Okay, cool. Those are the 2 sides of your triangle. So let me draw this out. In this space, I'm going to draw a triangle. I could label side 1, which we had above, as 1, and side 2, which we could say is the opposite side, is x. Is this the only way we could draw our sides? What could I do instead, Fatima? Okay, so switch them around. Take the adjacent side, switch it to the opposite. Take the opposite side, switch it to the adjacent, just switch the 2. You guys understand what I'm saying? Switch the 2 sides. The main thing I want you guys to realize, this is why it says answers may vary, because there are multiple answers you can get. For all of these questions, I'm going to show you how to get 2 of those answers. Okay, so I have the triangle that I have here. Let me ask you this. If I wanted to find the hypotenuse for this, what could I do? There's two things I could do. What's one of the things I could do for this? What can we use to try to find the hypotenuse? We can use Pythagorean theorem. But what did I tell you it was at the top of the page? All of this, the square root of 1 plus x squared. This is the hypotenuse. I literally told you this. So without even having to solve, I'm going to write this as a square root of 1 plus x squared for both of them. 1 plus x squared for both triangles. So what we need to find is the composition. So to find the composition, I first want to make a little note here, and I'm going to write this at the top of the page. In order to find this ratio, so for your starting ratio, which is the ratio that I have in the parentheses, to find that, I want you to pick this fraction. I need you to have a power of some variable x and then a number. So this is how it's going to look. It's going to be some power of x, so x to the first power, x to the second power, maybe 3x to the first power, all over some number. So like 1, 2, 3, 4. That's how we're going to find our ratio. So in this question that I have, just focus on the top triangle. In this triangle, you have two variables. You have this ugly mess and this mess. Which one's nicer to look at? The x or the square root of 1 plus x squared? Just x. Hopefully you guys agree with me. Just x. That's the simpler one to look at. That's your numerator. Which of these sides have just a number? 1. The adjacent side, which is just 1. That's your ratio. So we'll do the same thing down here. It's the exact same stuff, it's just written differently. In this triangle, should be probably the same. Which side has the nicest variable? The adjacent, which is x. And what side has just a number? 1. The opposite, which is 1. That's going to be your ratio. Of course, you can simplify the ratio as x over 1 and just make it x, but we're not going to worry about doing that for now. The next part says find the trig inverse. Okay, the trig inverse, guys, that's going to come from your ratio. So this x over 1, let me show you guys what I mean. In this triangle, x is opposite, 1 is adjacent. What trig function is that referencing if it's opposite over adjacent? Tangent. So I'm going to put my little inverse symbol, and I'm going to put tangent. If you do tangent inverse for this triangle, you'll have the opposite over the adjacent, which is x over 1. What about the triangle below it? We have the adjacent side, and we have the opposite. Be careful. This is cotangent. So I'm going to write the inverse, and I'm going to write cotangent. So let's take a second and look at both of those. Do you understand how I got that inverse? I'm looking at the ratio to see how to get that fraction. So tangent will give me x over 1. Cotangent of this triangle will give me x over 1 as well. All right, last part is the trig. So this is just a regular trig function, sine, cosine, tangent, secant, cosecant, or cotangent. In this triangle, to find trig, the first one, you're going to look at the answer they gave you. In this answer, Odalis, at square root of 1 plus x squared, where is that on this triangle? It's on the hypotenuse, and it's over x. Where's x on this triangle? Opposite. So think about your sine, cosine, tangent at the top. Where is hypotenuse over opposite? I'll give you a hint. It's a reciprocal. I know it's going to look like sine, but do the reciprocal for sine. What's the reciprocal function? Cosecant. So this will be in parentheses outside, CSC. That's all you're doing, guys. Just work from the inside out. So I'm going to do the same thing for this last one. We're going to look back at the answer they gave you to try to figure out what sides we're talking about. The square root of 1 plus x squared. Okay, so Odalis, that's still the hypotenuse down here, right? Okay. Now look at to see, because I'm going to scroll it back. Where is x on this triangle at the bottom? Which trig function will give you hypotenuse over adjacent? Secant. S-E-C. Had to fit that in, but secant. That would be your answer. So on the back side of the page, guys, I'm going to do one more question with you, and you're going to do the last one. You can probably do both. So if you want to do both, feel free. But I'm going to do letter B with you on the back. All right, so on the back side of the page, I already have SOHCAHTOA at the top. I'm going to do letter B here. This will be 3x over the square root of 1 minus 9x squared. All right, so let's look at this guy. Okay, well, this is a little different. Even if, and I'm going to kind of flip back for just a second, even if this radical was in the denominator, this would still be the hypotenuse. So just keep that in mind. If this radical was in the denominator, this would still be the hypotenuse. Does this radical look like this one? They do look similar, but what's the only difference between them? This one's negative. Luckily, we did these on the back side of the page. When we had this negative, think back to the triangle they gave us. Hussein, what did they give you in this triangle for us to get 1 minus x to the 1 minus 4x squared? What did they give you on this triangle? Okay, they gave you the hypotenuse, and what else? And the adjacent side. So it could either be the adjacent side, or it could have technically been the opposite. So when you have questions that look like this, I'm going to make this little note. For questions like this, you're going to be given the square root of the hypotenuse, which they've already squared, minus the side, one of your two sides, which of course is being squared. I want you to keep in mind, guys, because sometimes I am a jerk. I might switch these numbers around. Your side, if it's underneath this radical, should be negative. The hypotenuse is always positive. So it's always going to be positive. So for this question, let's go ahead and figure out what our graph is going to, or our triangle is going to look like. So we're going to have, you guys told me, a side, and you're going to have your hypotenuse. So Chelsea, what's going to be your side? What am I going to take the square root of to find your side? Look at your radical. Look at your radical here. What's the side? What's just the side? This is the side I'm looking for. Which of these two am I going to use for your side? 9x squared. And then the hypotenuse for this is going to be the number in front. This number for your hypotenuse, guys, always has to be positive. So I'm going to square root this. The square root of 9x squared is 3x, trying to finish. And the square root of your hypotenuse, which is just 1, is just going to give you 1. So I'm going to create two triangles. So my first triangle over here, you can pick whatever side you want for the 3x. I'm going to put it down here as the adjacent side. The hypotenuse should be 1. In the other triangle, I have to do for sure, this 3x is no longer adjacent. I'm going to make it the opposite side. The hypotenuse, though, is still going to be 1. If I was to ask you guys to identify the missing side length, you could do one of two things. You can either do Pythagorean theorem, or you can just use what you have here, because we've already proved this on the last question for 14. If you were trying to find your missing side length, if you do Pythagorean theorem, you will get this ugly radical. So I'm going to rewrite this as the square root of 1 minus 9x squared. And if you don't believe me, you can always solve it using Pythagorean theorem. All right, so now we need to write our answer. My ratio. Okay, so let me look just at the first triangle here. For my ratio, the easiest x that I can find is 3x. That's the best one that I can find. So for my ratio, I'm going to put this in parentheses. We're going to put a 3x. For this first fraction, I'm just going to find the one that has a number. The only side that has a number is your hypotenuse. So I'm going to put that 1 in your denominator. This ratio, guys, needs to be the exact same for the other one. 3x over 1. And if you don't believe me, look at it. The easiest side is 3x. The easiest number is 1. All right, so looking back at the first one, I'm focusing on the first one. I need to write the inverse for what this ratio means. Okay, so in this triangle, this ratio represents the adjacent side and the hypotenuse. Okay, well, let me look back at SOHCAHTOA. Adjacent and the hypotenuse represents cosine. So next to that inverse, I'm going to write out cosine. I'm going to finish this one first before we do the other one. For this first triangle, if you're looking at the original ratio, where is 3x on this triangle? What side? The adjacent side. And we're going to put that over, what is the denominator? This radical is the opposite side. All right, so let me look back at my SOHCAHTOA. I don't have adjacent over opposite, but I do have opposite over adjacent. So what does that mean your trig function is going to be for the beginning? Cotangent. All right, let's finish this up really quickly for the second one. Okay, ignoring the first, I have 3 over x. Okay, in this triangle, not the first, this is opposite and this is hypotenuse. Okay, so for this ratio, inverse, I'm going to write the opposite over the hypotenuse, which if I'm not mistaken is sine. So I'm going to put sine inverse. How do I get the trig function in front? What do I have to look at again? The original. You look at the question they gave you. So the 3x in this triangle is now opposite. The square root of 1 minus 9x squared is now the adjacent. Oh, that one's easy. Opposite over adjacent, that's just tangent. What I want you guys to do right now, I'm going to give you about 4 minutes. Let me zoom out. I want you to try letter C. I will give you this little hint as I'm rewriting it. I'll give you one little hint. When you're multiplying this as a fraction, how can you rewrite it to make it easier for you? How can you rewrite it? Go ahead. That's what you're solving. I'm giving you 4 minutes. Solve it. When this time goes off, or when the timer goes off, I'm just posting up the answer. I'm not going through it. So this is the solution you should have found. You should have had 4x over 3. That's pretty much coming from taking the square root for both of those numbers. Based on what triangle you have, one of them should have cosine inverse, the other one should have sine inverse. And then for the actual trig function outside, notice there's no inverse, it's just sine and cosine. So those are the only two things you have. If you don't understand how I got one of those two, you need to let me know.